All right, so we're going to be working on probability of two events. Now, there are two types of events that we could be dealing with. We could have independent events or dependent events. Independent means that you have two or more events that do not depend on each other. Okay, so an example of this, quiet please. Okay, the example of this would be rolling a dice and then flipping a coin. Okay, the dice has nothing to do with the coin, therefore those would be independent events from each other. And dependent events are going to be two or more that do depend on each other. So an example here would be if you have a deck of cards and you pulled an ace out. And then if you didn't put that ace back into the cards, it would change the probability of the rest of the deck. So that's dependent. So when you have one event, depends on another event. So first thing we got to ask ourselves is, are these events independent or dependent? So I have some examples. The first one here is you roll a 2 on a 6-sided dice, and we're asking ourselves, what is the probability of this happening? Well, we've done that before. Rolling a 2 is one singular event, and the 6-sided dice is a 6. Okay, so 1 out of 6 rolling a 2. And then rolling a 3 on a second 6-sided dice as a probability of 1 out of 6. Now, these are independent events from each other because the first dice and second dice do not conflict at all. And when you have two individual events, the way you find the probability between them is you multiply them together, which means that even though it's a 1 out of 36 or a 1 out of 6 chance to get a 2, and then a 1 out of 6 chance to get a 3, getting a 2 and then a 3 has a 1 out of 36 chance. Okay? Two probabilities should always be multiplied together. Okay, so here Mr. Schmidt picks someone to go up to the board from a group of 15 students, then picks a second student to go up to the board, different than the first. First student is a 1 out of 15 chance, and the second student is going to be a 1 out of, now this is where it's different, it's 1 out of 14, and this here is a dependent event because the second student depended on the first. So it ended up being a 1 out of 14. Well, 1 out of 15 times, or we're looking for 15 times 14 here. So that means in order to get two specific students, it's 1 out of 210. Okay? So, dependent practice. You have $6 bills, you have 8 $10 bills, and 3 $20 bills. Now this is 6 $1 bills, 8 $10 bills, and 3 $20. Everything here is going to be with our replacement, meaning if I pull a 6, I'm not going to put that, or I pull a 1, I'm not going to put that 1 back into the deck. Okay? So, the probability of pulling a $20 bill and then a $1 bill. Well, the 20 is 3, and I know that there are 17 total here. Adam? There are 17 total here. So I'm going to go 3 out of 17, and I'm going to multiply that by the $1 bill, which now there are not $17 anymore. There are 16 because I left one out, and there are 6 $1 bills. So now in order to get the probability between them, I'm going to multiply these out, which is 18 over 17 times 16, which is 272. Now I can divide by 2 because they're both even, so I get 9. Which is 136. And I think that is fully simplified. And it ends up being about 7%. Pulling two 10s back to back would have an 8 out of 17 probability on the first, and a 7 out of 16 probability on the second, because I wouldn't leave that 10 back in. So then here I do 8 times 7 is 56. 17 times 16 is 272. 56 divided by 272 ends up being 7 over 34. One sec. Okay, so we're back. Now here, I want to pull a 10 and then a 50. Well, the pulling a 10 would be 8 out of 17. And pulling a 50, well, there is no $50 bill, so that's a 0 out of 16. So I get 0 out of 272, which is 0, or 0%. Alrighty, so let's do some independent practice. Each team has a 50-50 shot of winning each game, meaning they have a 1 out of 2 chance to win. So it asks you, what is the probability of winning 2 games in a row? Well, if you have a 50-50 chance of winning game 1, that's a 1 out of 2 chance to win game 1. And if you have a 50-50 chance of winning game 2, that's a 1 out of 2 chance to win game 2. You simply multiply those together to get a 1 out of 4 chance to win both games in a row, or 25%. Losing 2 games in a row. Well, if you have a 50-50 chance of winning, you have a 50-50 chance of losing, so it's 1 out of 2. Multiplied by the same probability on the back, 1 out of 2, which multiplies out to be 1 out of 4, or a similar 25% chance. So we just learned that you have the same probability to win 2 games as you do to lose 2 games. Okay, now 4 games in a row is the same thing. You have a 1 out of 2 chance for each game, which means that you simply multiply these all together. 2 times 2 times 2 is going to be 1 out of 16. And there's your probability. All right? So I'm going to have you try these and see how they go, and bring these to class tomorrow. Okay, so we're done. Let's, whoops, give these a try here. So if rolling 1 6 is a 1 out of 6 probability, rolling another 6 would be another 1 out of 6 probability because they don't depend on each other. So your answer here is 1 out of 36, or about 3-ish%. If you have a 1 out of 6 chance of making a 3-pointer, that's going to be 1 out of 6 times 1 out of 6 times 1 out of 6. So the probability of making 3 in a row would be 1 out of 216, or a very, very small percent, about 0.5%. And the last one, you have 5 red socks and 3 green ones. Probability of pulling a red is a 5 out of 8, and then pulling a green would be a 3 out of 7 because you wouldn't put the sock back in. So you end up getting 15 out of 56. Which is about 25%-ish, around in that range. All right, so that's all I got. Bring it to class tomorrow.